Hey guys, welcome back. In this lesson, we'll be exploring implementing caching on our API. Now, caching can significantly improve the performance of the API. Just think about when we have hundreds, maybe thousands of clients subscribing to the API. They're all trying to find out hotels and countries and probably even both at the same time. And that can really take a toll on the performance of the API based on the whole infrastructure and the fact that you have to hit the database with every request. So caching will introduce a kind of quick access layer on top of the real data store, and it will significantly reduce how often we have to pull the database. So what we will be implementing is one, caching. We'll be looking at implementing an expiration mechanism to reduce how often we have to go to the database. We'll be looking at implementing a validation mechanism to reduce the network bandwidth. And at the end of this lesson, we just want an overall feel of caching, why we have it, and how it can be implemented. Now, there are three types of caching, and I just want to give you guys a little theory before we get into the whole code matter. So the client cache lives on the browser. So it's a private cache because it's unique to a single or any particular client. All right, we have the gateway cache, which kind of lives on the server and is a shared cache. So the gateway implements a cache, and all the clients hitting the gateway at any point in time would be hitting that cache. And then we have a proxy cache, which is also a shared cache, but it doesn't live on the server. It lives in the network. Now, to start caching a resource, it's pretty simple. What we need to do is add the response cache attribute and set how long the cache should live for, right? So over any over any endpoint, and I'll just start off with countries, we just experiment between these two. So I'm just going to add the attribute that says response cache and then duration equals 60. So 60 means 60 seconds. All right. So we're setting up cache control with a maximum age of 60 seconds. If you look at duration, you see this sets max age in the cache control header. So when a client queries for data from the endpoint, there will be a header included that says this is the lifetime of the cache that you are now getting, or cached data that you are now getting. So let's go into debug mode and conduct a quick test. In Postman, what you want to do is just make sure that your send no cache header option is off. So you can just go to file settings and under general, just look for that setting, make sure it's off. Otherwise, you can proceed. So we already know that we can look at all the headers coming back. And I'm going to do send. And when we get the response, we see that our cache control header is coming back and it has the max age of 60. All right. Now, this is really just a header. So we are not actually caching anything just yet. This is just letting the client know that, well, the data is cached. But of course, we actually need to cache the data. So we're going to have to modify some of our configurations in our startup, which is where I started off. So in our startup.cs, we're going to add this new service registration in the configure services function. And that I'm just going to put right here. So services.add response caching. And then after that, we need to register our middleware, which I will do right above the routing middleware that says app.useResponse caching. So you can just go ahead and add those two lines. And then what we're going to do is do another test. And when I run this request, we are seeing a new header. And this one says it indicates the number of seconds the object has been in a proxy cache. All right, so we just talked about the different kinds of caching. So now we're implementing a proxy cache, and you see the value here is 9. So if I run another one, then you see it's now 32 seconds into the maximum age of 60. So pretty much within the lifetime, if we continue to poll it, we would keep on getting a different value for the age. So when I do that, you see the age is gone because we exceeded the 60 seconds. So it actually went to the database this time, came back, there's no age. But then if I poll it again, Now it's telling me that, okay, it's 10 seconds old, it's 14 seconds old, etc., etc. Now I'm just going to go back over to my startup file real quickly, and we're going to explore how we can probably implement a more global value. Because right now I would have to set this manually over every action or every endpoint, and then if we change it from 60 to 120, then I would have to go through each one. So what we can do in the startup is add to the config for add controller. So I'll just put in my Lambda expression. We know we have the token and we have the arrow, and I'll just put in the curly braces because if we have more than one lines to configure, that makes it easier. But what I'm going to add is a config to say cache profiles dot add, and we want the 120 seconds duration. So here we can kind of define a cache profile, which then we can use and reuse throughout. So I need, let me see what I need here. I need a semicolon at the end. All right, there we go. So config.cacheprofiles.add, and we give it any name. I mean, within reason. And then new cache profile, duration, and you can add other properties to the profile, location, variable, header. It won't get too complicated. But what we can do now is, instead of specifying duration here in this header, I can say cache profile name is equal to, and then we put that name that we just specified in that slot. So if you want, you can go ahead and test it. I'm not going to test it again because we already get the gist of the headers coming back and the age. So now we've increased it to 120, and over any endpoint that we wish to have that cache, and more than likely you'd want it over the ones that are reading the get profiles would be the ones to have that caching profile. You wouldn't necessarily need that over the create and other operations. All right, so let's talk about a situation where our data might get stale. So as I said, with the cache, it takes like a quick copy of the data layer and it returns that data for as long as we told it to. So in this case, it's 2 minutes, but let's extend this to maybe 10 minutes. And then the first time the client, tries to get data, then it's going to hit and then get a cached version afterwards. But then what if 5 minutes into this 10 minutes or 2 minutes into this 10-minute period, an update actually occurred? So a new country got added, right? And then they're still getting stale data for as long as the cache is alive. So we don't want that. We don't want that. When the data changes underneath, they're still getting old data. So what we want to add to this is some validation. All right. So to do some validation or add headers for validation and expiration checks, we're going to include a new library, and it's going to be this library called marvin.cacheHeaders. All right, so ASP.NET Core middleware that adds HTTP cache headers to responses. And you see the different headers: the cache control, expires, ETag, and last modified. All right, so it implements cache expiration and validation. So you can go ahead and get that. And I'm going to refactor our code a bit. So in the service extensions, I'm going to add a new function where we're saying public static void configure HTTP cache headers, and we know the drill. We pass in the service collection, and then I'm taking that first line that we added, services.add response caching, as well as services.add HTTP cache headers. So we're taking those two, and then what we're going to do is just add a reference to the startup. So where I had the original one, I'll just add one reference to that function, which is going to initialize these two service calls. All right. After that modification, we're going to add the middleware. So after the use response caching, I'm going to add app.useHTTP cache headers. And before we do any more modifications, just to make sure everything is okay, we're just going to do a quick test, and we're going to send a brand new request. And when we look at the list of headers coming back from that request, look at it. We have expires, we have last modified, we have an ETag, identifies a specific resource version. So it's just like a little hash that says this is the version of the data you're getting, vary, and other things. So we see that we're getting back some new headers along the way, right? You would also notice that the max age is kind of gone back to 60. So yes, it was 120. We set it to 120, but it's gone back to 60. So we're going to just explore how we can customize that max age. And the way we're going to do that is go back to our service extensions and add the following code on the services.add HTTP cache headers. So we're going to define a token, call it expiration option, lambda arrow, and we're going to say expiration option, max age 65, 120, whatever it is that we want. We can say the expiration option dot cache location. We want it to be private, or we want it to be public. So remember that you saw public or private. So let's say we wanted it private. And then the validation option, we say must revalidate equals true, meaning once the data has changed, we must go through that process again. Now, after doing these modifications, we can actually remove the header from the resource. All right, so let's just do one more test. And we'll see that the modification is actually global. All right, so even without putting the resource, the attribute right above the resource, we see that we're still getting back the same headers, and I'm just gone 111 out of the life of the 120. All right. So the next thing I want to show you the next things I want to show you would be the custom attributes that you can actually add right above the potential endpoint that you want a different setting for. So yes, we set the global setting in the in the service configuration, but then over the endpoint, you can actually override that. So you can just add those missing references. So HTTP cache expiration, and then you say you want a different location, you want it to be public, and this one should be 60. You can actually override the global settings right here. And then you can tell this one that it doesn't need to revalidate. So just bouncing back to the headers coming back now that we've implemented caching, just to go through them once again. This tag actually represents the unique hash to say this is the version of the data that you are seeing. If within the lifespan of the cache something changes, then this tag is actually going to change, and then you would get a new tag. All right. But then for as long as the data store does not change, what we're doing is just caching it so that we don't have to hit the database to bring back the same data every time somebody wants it, at least for 2 minutes. If we get 1,000 requests, we don't necessarily need to go to the database for the same old data. So that is the advantage of adding caching to your API. Of course, on a case-by-case basis, you may want to, customize how particular endpoints serve up the data versus others. You may also not even need caching based on the application, or it may not be suitable for the type of operation that you are providing the API for. So this is just another thing that I think it's good for you to know, and you can use it, have it in your arsenal for when needed. Hey guys, welcome back. In this lesson, we'll be talking about rate limiting. Now, rate limiting, or throttling as it is also called, is a technique by which we impose certain limits on how often somebody can hit our endpoint and actually get back data. So of course, if somebody comes and bombards the endpoint, as much as we have caching and all these things, the fact is that the endpoint is actually prone to a denial of service, or DDoS attack. And what we want to do is kind of put a mechanism in that when we detect too many requests from one source, we can kind of block them and say, hey, you're overdoing it. Outside of the potential DDoS attack, it actually helps us to kind of meter how often any one client accesses data. And many very popular APIs out there, Google and well, I'm just going to say Google, but all of those big players with APIs and their SDKs, they all have some form of throttling. If you read the requirements and the terms of use of their APIs, they all have something in there to say you can request maybe 100 per minute or 100 per hour, stuff like that. So today we're going to be setting it up in our API just to get a feel of how it's done. And we'll be using the library ASP.NET Core Rate Limit. So we can just go ahead and install that. And once that is installed, the next thing that we want to do is go over to our startup and allow our application to use memory cache, because it's going to use memory cache to kind of store and keep track of who requested what and how many times they've requested it in the timing, right? So we can just say services.add memory cache right there in the configure services function. And then we have some modifications to make to service extension. So I have the code here already, and this method is called configure rate limiting. And we already know the drill about the service collection. And what we're doing here is setting up a set of rules. So you can just go ahead and copy the code and include any missing references as you go along. So var rate limit rules equals new list rate limit rules. So you can have multiple rules. So we have to initialize a new rule object, which allows us to specify the particular endpoint. So in this case, I'm saying star, meaning every single endpoint is going to adhere to this rule. So based on this structure, I can actually have multiple rules. I can say comma and do a new rule. All right, let me just copy and paste. I can do a new rule, specify a particular endpoint, and then change the limit. So this one says you're limited to 1 call per second. Right? That's kind of short. I mean, we can say 10 seconds, 1 call every 10 seconds. I can say 1 call every 10 minutes, or 100 calls. It's up to you. You can configure it. And once again, if you have different rules per endpoint, you can go ahead and add these rules and specify the particular endpoints to which they are applicable. Right now, I'm just going to set a global rule. So I'm just going to say all endpoints, and I'm going to set it to something that is very small so that we can see it in test, right? So I'm going to say within 5 seconds, you're only allowed 1 call on any endpoint. Then we go ahead and we say services.configure, and we put in the IP rate limit options, and we just say options.general rules equal the rate limit rules that we just defined. Outside of that, we need to add these singleton services in the form of I rate limit counter store, and that is going to be associated with memory cache rate limit counter store. So all of these are just bits of code that are required to support the library that we imported. So a different library might implement it differently, but this is the code required for this particular library. So you can just hit pause, write them off. At this point, IntelliSense will be filling them in because you already have the package. Now, after we're done in service extensions, we're just going to head back over to startup, and we're going to add these 2 lines. Services.configure rate limiting, which is the method we just configured, and services.add HTTP context accessor. So this gives us access to the actual controller and its inner workings when needed. And then finally, we're going to add the middleware where right above routing. So I'm going to put it right underneath the caching. We have app.use IP rate limit, and of course include any missing references. Now, there have been different response codes used when they're responding to say too many requests. In more recent times, 429 has been used, which literally means too many requests, but in the past I've witnessed platforms using 420, which means enhance your calm, and other ones. So let's test this out. So for country, I'm going to hit send. And if we observe the headers, we'll see that we get back 3 new headers: X rate limit, X rate limit remaining, and limit reset, right? So it's showing you that the limit is 5 seconds. You have no more remaining for the 5-second window, and that the reset is going to be at this timestamp. So if I hit this multiple times, All right, I'm going to use a different endpoint because I think this one is protected by caching. So it might not, based on my caching configuration, it's not going to violate the throttle. All right, so I'm going to use the hotel because remember that we set up all of those things on the country endpoint. So let me go to hotel, which I didn't really modify as much. So I already sent a request and it's showing me the same headers, rate limit, etc., etc. If I send another one more than 5 seconds later, it's okay. If I send another one, too many requests, right? So it says retry after, and it's basically saying send another request after 1 second. So nothing came back but the message API calls quota exceeded maximum admitted 1 per 5 seconds, right? So it's letting me know that I need to try back in this amount of time. And when I do, there we go. If I try again, retry after 4 seconds, try again. And if I keep on doing that, you see that that value keeps on changing relative to the number of seconds that I have based on the last request. So that is how we can add throttling. And it automatically, once again, gives back that 429 to say too many requests. All right. And that message, so the client knows that, hey, you're bombarding the API, enhance your COM.